Okay, I'm going to make a video real quick going over the homework from 6-8, applying coordinate geometry. This was the homework assignment that was on pages 410 and 411, 7 through 29. Number 1 through 12. On these, we're just finding what is the coordinate of the vertices of each figure. And on this one, it says it's a rectangle with a base of B. The base is B, so that means this is B as well, and the height H. So the origin, O, would be 0, 0. W, we went over B and stopped B0. To get to T, we went over B and up H, so BH. And for S, we didn't go anywhere left or right, we just went up H. So those are the coordinates. These probably should be alphabetical, and I didn't put them alphabetical as I should have. Should have said O, S, T, W, and I put them in that order. But number 8, it's a square with side lengths A, so they're all A. So the origin is 0, 0, W is A0, T is AA, and then S, 0A. Remember on the y-axis to put the 0 first. Number 9, it's a square centered at the origin with sides length B. Well, if each side is B, if it's centered at the origin, then it's bisected. So these are B over 2. Each one is half of B. That's just a little more of a challenge. You just have to figure out what the coordinates are using half B. So we didn't have to name this. We named W. We went over B over 2 and up B over 2. For Z, over B over 2, down B over 2. For T, over negative B over 2 and up B over 2. And then for S, over negative B over 2 and down negative B over 2. So those were our coordinates in alphabetical order in that case. Number 10, a parallelogram where S is A units from the origin and Z is B units from the origin. So S is A units, so this distance here would be A. Z is B units, okay? So that means that Z is going to be B0. S is going to be 0A. That's how far those two are away. Then I used the next one closest to the origin, T, and said I went over C, but I went up A because I went up the same amount I did for S. So I went over C and up A. And so when I'm figuring out the x coordinate for W, I go over Z plus C. Because when I said this was out C, that's the length of this side, so it also the length of this side. So I had B plus C, 0. That's what the coordinate of that one would be. You have to pay close attention with parallelograms, make sure that you're doing that. And the best way to name the variables are going away from the origin. We probably should have named S, then Z, then T, then W. And if you'll use letters like A and B, you won't get so confused. Sometimes it's a little easier. Now the next one, I just said that, but on this next one, we're using T's and R's because it says as a rhombus is centered at the origin, SW is 2R, so R and R. ZT or TZ is 2T, so it's T and T. So we had R0 for W, 0T, and 0 negative T for T and Z, and then S would be negative R0. Okay. And the next one, an isosceles trapezoid with a base centered at the origin, with bases 2A, with base 2A, and OR is C. So this was 2A, that was the base. So that means it's A, and it's centered at its origin, so it's been bisected. And this goes up C. Now, they didn't tell us this base, but of course, I'm naming it, saying that it's basically 2B. That's how long that base would be, making this one a BC. But anyway, we'll start, since this is A and this is C, then this was A0. This would be negative A0. Since the height here is C, I just said I went out B and up C, and then this would be negative B and up C. So I had to come up with a B on my own. So you could have put a different letter other than B, but since they're using A and C, then B falls in the middle. I have to use that. All right, number 13, it says the diagram shows a parallelogram without using the distance formula to determine whether the quadrilateral is a rhombus. So it is a parallelogram. Now we could use distance formula to find the length of all four sides to show that they're congruent and it's a rhombus. But the easiest thing to do, what we've been trying to do, is Work smarter, not harder. Slope formula is much easier than distance formula. So if we find the slopes of the diagonals AC and BD, the slopes of those two came out to be -1 and 1. Those are opposite reciprocals. So it's a parallelogram with perpendicular diagonals, which means it's a rhombus. So ABC is a rhombus because the diagonals AC perpendicular to BD with slopes opposite reciprocals. So that's how I show that it's a rhombus. Okay, number 14. On number 14, on this problem, they tell us to plan a proof. Now, I completed the whole proof. They said plan the proof. They had the picture for us, and then they gave us some information like this base was 2A. Well, actually, this base was 4A long, so it's 2A and 2A when we divide it in two. This was 4B, this base, so it's 2B and 2B, because this is centered at the origin, it's divided in two, and they told me that EG was equal to 2C. So using that information, I was able to get my coordinates. So from the origin, I went over 2A, 0. Okay, this, I went out 2B and up 2C. This one, we went over -2A, 0. And this one went over -2B and up 2C. So those are the coordinates of the isosceles trapezoid. T-R-A-P, trap is what they called it. So that's the order I put them in. That's my trapezoid. Now, for planning a proof, we also have to write the given and the proof. And they're saying in this isosceles trapezoid, we're supposed to prove that this, the quadrilateral connecting the midpoints of the sides, is a rhombus. So my given is that TRAP is an isosceles trapezoid. I'm supposed to prove that DEFG is a rhombus. Then they asked us to see how would we find these coordinates since they're midpoints. Well, we would use the midpoint formula to find those coordinates. And I went ahead and did the proof. All you had to do is say use midpoint formula to find the coordinates of the midpoints. But I went ahead and did it just to illustrate how the whole proof would work out if you did it. So here are my coordinates of D, E, F, and G using the midpoint. Okay, here are the coordinates. All right, so, and they make sense. G is 0, 0. F was A plus B, C. And then this one was, and remember, we use these 2's on the coordinates so that when we use midpoint, we don't have a denominator. We don't have a fraction. All right, so those are the coordinates now, and we're supposed to prove that this is going to be a rhombus. Now, the way we would do it, the way we prove the precise name of any quadrilateral, we start with slopes of the sides. So the slope of the sides using these points. When I found the slope of the sides, they're odd slopes, but we can still tell that this one and this one's equal, that one and that one's equal. So that means it's a parallelogram. Both pair of opposite sides are parallel. Well, remember, we're supposed to prove it's a rhombus, so both pair of opposite sides are parallel. It should be a parallelogram. It's not a rectangle because those aren't opposite reciprocals. One of them's not flipped over to make the other. Then I found the slope of the diagonals. And the diagonals came out to be 0 and undefined, which means one's vertical, one's horizontal, so they are perpendicular. So that's how I know it is a rhombus. It's a rhombus because it's a parallelogram, because both pair of opposite sides were parallel with equal slopes. It was a rhombus because the diagonals are perpendicular with opposite reciprocal slopes. So that's how I knew what it was. Number 15 wanted us just to place a general quadrilateral in a coordinate plane, okay? Now, when it said general, what that's referring to is that we just use variables as our coordinates. It didn't have to be. I made sure that I did one that I thought would be no sides congruent, no sides parallel, or anything like that. But it didn't have to be that way. You could have placed a parallelogram, a triangle. You could have placed a parallelogram, a rectangle, a square, isosceles trapezoid. It would not have mattered. But this is the way I did mine, just to do it differently. So I said this Q was 0, 0. This would be A0. I said this one would go over B and up C. And this one went over D and up E. So I had to use a lot of variables, which is not the greatest placement. Now, they do tell us to always put one side on the x-axis if we can and a point on the origin. That makes it a little easier. But if you don't have something that's, like a rectangle or parallelogram or whatever, then all of these points have unrelated variables in them, which makes it a little harder when you do proofs, but you can still do them. Number 16 says a rectangle, LMNP, is centered at the origin. M is R negative S. What is the coordinate of P. So centered at the origin means the origin is in the center, right? And so it's a rectangle because it's a little longer than it is wide. If M is at R negative S, and this thing is L, M, N, P, P is the opposite vertex, so it's going to be the opposite quadrant, so all that changes is the signs are opposite. So if this one if M is R negative S, this would be negative R S. All right, number 17. 17, 18, and 19, you were supposed to name the coordinate of P in the picture. So you have, this would be 0, 0, C, 0. This is AB. So now, unlike a parallelogram, if you think about it, this goes up in this direction. And this part here would be the same as this part here. So actually, we went to C and came back A. So it was C minus A, B. That's the answer. That's what it should say, C minus A, B. Because we went out to C, but we came back this amount, which was A. So we came back A. So C minus A, B. Number 18 is really, really easy. Since this is at AB, that meant they went over A and up B. So that means P directly below it would be A0. And then the kite on number 19, really simple. If this one is B0, this had to be negative B0 because this diagonal of the kite has been bisected. Number 20, you were supposed to draw a square whose diagonals are linked to B and lies on the X and Y axis. So that means that my square had to be turned this way because its diagonals are going to be the X and Y axis. Since their length is 2B, a square, we know the diagonals are congruent and they bisect each other. It's congruent because it's also a rectangle and the diagonals of a rectangle are congruent. So I made all these B, 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 B. That's their lengths. So this would be B0, 0B, 0 negative B, and negative B0. Those were my coordinates. So that was the B part. Find the coordinates of the vertices of the square, and there they are. I called it SQURs for square. It says compute the length of the sides, or a side, the length of a side, because all the sides will be the same. I chose SQ, so between 0B and B0, here was the distance formula, and I got B square roots of 2 as the answer. No matter which side you chose, you would have got B square roots of 2 as your answer. Then D says find the slope of 2 adjacent sides. Now you could have found 2 different sides. I found this side and this side. You could have used these two. It would have mattered. Just consecutive sides. Your slopes, one of them would have been negative 1, one would have been positive 1. Those are opposite reciprocals. Because it says next, right, do the slopes show that the sides are perpendicular? And the answer is yes. Slopes show sides perpendicular because they are opposite reciprocals. Okay, so that was number 20. You're just answering the questions A, B, C, or D. A lot of these questions are like proofs, but they're, of course, not proofs. This is planning for a proof. This is getting ready to do complete proofs. On the next one, it says make 2 drawings of an isosceles triangle with a base length 2B and a height 2C. In drawing 1, place the base on the x-axis and the vertex at the origin. So a vertex, it's a vertex, not the vertex. This is the vertex. It's between the 2 congruent sides, but a vertex is at the origin. A side is on the x-axis. Okay. The length of the base is 2b. The length of the height is 2c. So this point would be 0, 0. This would be 2b, 0. And this would be b, because it's been half, it would be b, 2c. All right. The other one you're supposed to place so it centers at the origin. So the base is centered at the origin. So if that's 2b, this is b, and this is b. I probably should have put that measure in there, b and b for these. So that's b0, negative b0, and this would be 0, 2c. So then it said find the lengths of the legs of the triangle in part A. So for xz, using these 2 points, I found the leg, and it was the square root of b squared plus 4c squared. It had b minus 0, b minus 0, and then 2c minus 0. B minus 0 would just be b squared. 2c minus 0 would be 2c squared, which is 4c squared. Okay, so that's how I got that. Then I found the length of this one, got the same thing. D, I found the length of this one, same thing. The length of this one, same thing. And it should be. These triangles are congruent. So the length of those legs or those sides should all be congruent. And even though it's odd, it's got variables, you can still tell those are equal. They have the same value. And then E said, how do the results in part C and D compare? They are the same, and that's what they are. So if you were doing a problem like this, because the way they describe these isosceles triangles with the same base and same height, triangles have to be congruent. So you know these are going to come out equal. So if something happens while you're doing this one, and it's not the same thing, check your work. Check your work, because they should all come out to be equal. Okay? All right, number 22. 22, this was a kind of a long problem in some ways. We had these three pictures, and we're first supposed to find the midpoints W and Z in each one. See, W is the midpoint of RO, Z is the midpoint of ST in each one. Okay, so you were supposed to find those midpoints. So I found the midpoint in this one, and it was A plus B over 2, A plus 0 over 2, B plus 0 over 2. See? And I got W was A over 2, B over 2. To find ST, it was C plus E over 2, D plus 0 over 2. And this is what I ended up with. And notice I ended up with a 2 on the bottom because we're using midpoint formula. We divide by 2. That's why in this one they chose to use coordinates that had 2. It's the same coordinates, we just doubled them. 2C, 2D, 2A, 2B. It's the same coordinates, we just doubled them. And what did that do? It made the 2 in the midpoints go away so that we don't have a denominator of 2. Okay. Now the next one, they used the same points, but they doubled them again. 4A, 4B, 4C, 4D, 4E, 4, and 4E and 0. So they doubled those. And it doesn't matter. It's a length. We don't know what that length is. Whatever A is, it's 4 times that, but it's an unknown length. Now the reason they did that one, notice this time our midpoints come out with 2A, 2B, and 2C plus 2E and 2D. Okay. Now the reason we did that is because the next question says, you are to plan a coordinate proof involving the midpoint of WZ, okay, to find that unknown point. Which figure, A through C, would you prefer to use and explain? And the one that you should prefer to use would be C. Why? Because when we find the midpoint using these, the denominator 2 will cancel again. If we use this one, we'd end up with a midpoint with a 2 on the bottom. If we use this one, we'd end up with a midpoint with a 4 on the bottom. This would end up with a midpoint with a 2 on the bottom. This one, the midpoint is eliminated, and I went ahead and did it. I would use C, and I found the midpoint, or found out what this point would be. Midpoint of WZ would have been this. Still a strange midpoint, but at least we don't have a denominator of 2. All right, number 23. Number 23, we were supposed to plan a proof. The plan of a proof starts with a draw a figure, write your given in proof, then plan the proof. Tell me what formulas you're going to use and how you're going to use them. All right, we had to have a parallelogram, so I drew a parallelogram. This point was 0, 0. Then I named them as I went away from the y-axis, 0, 0, AB, C0, and then this would have been A plus C, B. Okay. My given in proof that's supposed to refer to my picture, PALR or PARL, is a parallelogram, and we're trying to prove that opposite sides are congruent, so I wrote the two pairs of opposite sides that we would show are congruent. How would I prove they're congruent? I'd use the distance formula to find the lengths of all 4 sides, and then see if PA is equal to LR and if PL is equal to AR. And they should be if it's a parallelogram, and we've named it as a parallelogram in our picture. Number 24, this one, we draw a diagram. This proof was to prove the diagonals of a rectangle bisect each other. Okay, prove that the diagonals bisect each other. So here's my rectangle. This time I named this one 0, 0, and I went ahead and said 2A0, 0, 2B, and 2A, 2B. And you may not understand why I put the 2's on there, because we didn't say anything about midpoints. Well, here's the thing. The diagonals of a rectangle are supposed to bisect each other. Okay. Now, one thing you could do, you could find the length of TM and ME, compare those. The length of RM and MC, compare those using the distance formula. That'd be a lot of work. That's 4 different distances. Or what we can do, if they bisect each other, they have the same midpoint. So what we could do is find the midpoint of this segment and the midpoint of this segment, and if they're the same, they bisected each other. So that's what I would choose to use, and I'm using midpoint formula, so that's why I use the 2's, so that the 2 that would be on the bottom of the midpoint formula will cancel. So my given and proof, I'm given it as a rectangle, RECT is a rectangle. I'm supposed to prove the diagonals, RC and TE, bisect each other. My plan for the proof is use the midpoint formula to find the midpoints of RC and TE, the diagonals. If the midpoints are the same, then they bisect each other. So that's the way I chose to do it, rather than using some sort of distance formula. You could use distance formula. It'd just be a lot more work. And number 25, plan for this proof. On this one, it said, we're going to prove that the consecutive sides of a square are perpendicular. Okay, so I placed my square like this. You could have placed it, I placed it where one side is the x-axis and one vertex is the origin. You could place it, center it around the origin if you wanted to. Wouldn't matter as long as you know it's a square, which means that the sides are the same. So I called this segment A0. Since the sides are the same, this would have to be AA. You go out and up the same amount, and this would be going nowhere and then going up A. So that way all the sides are the same, okay? So it's a square, and the way we drew it so that it appears perpendicular. The given is that SQUR is a square, and we're supposed to prove, as it said, that its consecutive sides are perpendicular. Consecutive sides are perpendicular. So I just chose a pair of consecutive sides. I didn't do all of them. We could have found the slope of all 4 and we would have solved consecutive sides, but I just chose one pair of sides, consecutive sides, SQ and QU. And my plan for the proof is to use the slope to find the slopes of SQ and QU and show that they are opposite reciprocals. Of course, we could have found the slope of all 4, and then we would have seen that all consecutive sides were perpendicular. But remember, it's a rectangle. If it's a rectangle, got one right angle, they're all right angles. They're all going to be consecutive the same way. All right, number 26. These are a lot like the problems in the previous assignment. It's just that we have variables included, not just numbers. If we're trying to find the most precise name of the quadrilateral, we first get the slope of all the sides. From there, we can determine if it's a parallelogram. If opposite sides are the same slope, then opposite sides are parallel. That's true for this one. Then we look at consecutive sides. Are they opposite reciprocals? The answer will be no. So it's not going to be a rectangle or a square because consecutive sides do not have opposite reciprocal slopes. Then we find the slope of the diagonals to determine, could it be a rhombus? We know it's a parallelogram. We know it's not a rectangle, but could it be a rhombus? By finding the slope of the diagonals, are those opposite reciprocals? No. So it's not a rhombus. It's just a parallelogram. And here are those 3 questions I said that can go in your explanation when you're asked your most precise name. It's a parallelogram because both pair of opposite sides are parallel with equal slopes. It's not a rectangle because consecutive sides do not have opposite reciprocal slopes. And it's not a rhombus because the diagonals are not perpendicular with opposite reciprocal slopes. That's how we know it's just a parallelogram. And number 27 was the last one that I said you were required to do. You didn't have to do 28 and 29. On this one, again, I'm trying to find the most precise name, so I find the slope of all 4 sides. But this time when I find the slope of all 4 sides, I only have one pair that are parallel. These 2 are opposites, but they're not the same. They're not opposite reciprocals. We don't have any right angles. There's no opposite reciprocals. These are opposites, but they're not equal. Now, I know negative and positive, you're going to think, uh-oh, I messed up. So check to make sure your signs are the same. And if they are, then, of course, it's not a parallelogram. It's only got one pair of opposite sides parallel, so that's going to be a trapezoid. So now we want to know, is it isosceles? And I take the 2 sides that would be the non-parallel sides, PO and OR are the parallel sides, so we use OP and QR and find their lengths. The length of OP and QR using the distance formula. And I got OP is T squared plus 4S squared. QR is T squared plus 4S squared. As long as they came out to be the same, that means it's isosceles. So it's an isosceles trapezoid. It's a trapezoid because only one pair of opposite sides are parallel with equal slopes. it's a trapezoid because of that. It's isosceles because the distance formula show the non-parallel sides congruent. Okay, so those homework problems, make sure you correct them, make sure you understand them. If you have any questions, I did include in the homework the answers for 28 and 29. I'm just not going to do the explanation here.